we will go over winter 2021 on test 4. Now, like before, make sure you round the decimal to 5 decimal places. There will be only 100 points available, but that's because I give extra 1 point if you provide critical values for each hypothesis testing we do. Okay. Now the test has how many pages? 7 pages. Okay, with the 1 hour I have left, there's a chance I can only do 2 or at most 3 pages. Okay, but I will show you at the same time how to use calculator to speed up our computation. Okay, number 1, in a study of 1,228 randomly selected negative medical malpractice lawsuits, it was found that 856 of them were dropped or dismissed. Now test the claim that most medical malpractice lawsuits are dropped or dismissed. Okay, so hypothesis. When we say most means more than 50%, right? That's what most mean. More than 50%. P is greater than 0.5. So that's the claim, and from there we know that's a right tail. Step 3, test statistic. That's proportion, so always C equals to, let me plug in numbers to my calculator. That will be 1 proportion C test, okay? And the P naught, the constant on the null hypothesis happens to be 0.5 already. The X, the number of successes, in this case, the one dropped, the lawsuit that is dropped or dismissed, 856, and the sample size is 1,228. We will do right tail greater than P naught, calculate. Okay, let me screenshot that so that I don't need to go back. Am I okay? Good. And I'm recording this also, right? Okay, so let me borrow this place temporarily. So what is my P hat? 0.69709 minus 0.5 over square root of 0.5, that's the P, times Q over sample size 1228. Let me write my P hat here also. My P hat equals to 856 over 1,228. That is 0.69707. Okay, this is actually 7, not 9. And that is, the C score is 13.81167. So step 4, the P value, that's a right tail. Okay, 13.81167. The P value is normal CDF. 13.81167 to E9901 That's 1 point something to the 10 to the negative 43. That's basically 0. Okay, informal conclusion. Reject null hypothesis. Okay, I'm actually done with this. I don't need this anymore. And then step 6, conclusion. Thomas, you don't even know your alpha. Well, because my p-value is 0. So I will reject null hypothesis at any cost, at any alpha basically. So at alpha equals to 0.03, there is sufficient evidence to support the claim that most medical malpractice lawsuits are dropped or dismissed. Extra credit 4B, critical value. That's a right tail with alpha 3%. So what is the critical value? C critical is inverse norm. The area to the left is 0.97, right? If the right tail is 3%, then the left tail to the right to the left is 97%. 0.1, that's equals to calculator inverse norm 0.97, 1.88079. 1.88079. That's for our number 1. Number 2. A vending machine dispenses coffee and a random sample of 27 filled cups, so n equals to 27, with a mean of 7.14 and standard deviation 0.17. Test the claim that the machine dispenses amounts with a standard deviation greater than 0.15. Use alpha 0.03. So the claim, the machine dispenses amounts with standard deviation greater than 0.15 ounce. So this is hypothesis test on population standard deviation. Unfortunately, our calculator has no way to, our calculator does not have a way to confirm that. Okay. So hypothesis. the standard deviation is greater than 0.15. So this is the claim, and that's right tail again. Step 3, test statistic. Chi-square is degree of freedom, 26, times sample variance, 0.17. Don't forget to square it. Okay, because that's for the place there is sample variance over population variance, 0.15 squared. I get 33.39556. And then p-value. That's chi-squared distribution, and that's right tail, 33 something. So the p-value is chi-squared CDF 33.39556 E99, degree of freedom 26. Lower bound 33.39556. Upper bound of very big numbers, degree of freedom 26. 0.15093. 0.15093. Oh, it's more than 3%. So informal conclusion, fail to reject null hypothesis. And finally, conclusion. At alpha equals to 0.03, there is insufficient evidence to support the claim. That the machine dispenses amount with standard deviations greater than 0.15. Okay, how about the critical value, 4b? It's chi-square distribution. You have area to the right. Alpha is 0.03. So chi-squared critical is inverse chi. Area to the right, I hope you remember that, for inverse chi. And degree freedom, 26. So we don't have inverse chi in our calculator, but we did program it ourselves. I hope you remember. Okay, make sure it's still on your calculator though. Okay, 0.03. Let's add it to the right, degree of freedom 26. 41.14605. 41.14605. Okay, now that's for number 2. Number 3, the campus at Joliet Junior College has a lake, and a student used a Secchi disc to measure the clarity of the lake's water by lowering the disc into the water and measure the distance below the water surface at which the disc is no longer visible. Okay, the following measures in inches were taken on the lake at various points in time over the course of 1 year. Now, these are the numbers. Okay, part A, use calculator features to find the sum of x, the sum of x squared, the mean, variance, and standard deviation. You don't need to show the work, but you need to show proper notation. Calculator time. Let's have party. I need to quit. Okay, so let's go to edit. Oh, I have list 1, 2, 3 occupied there. So stats, clear list. Stats, clear list. List 1, list 2, list 3. I basically want to start new. And I will enter these numbers into list 1. So 72, enter 64, enter 62, enter 66, enter 68, enter 43, enter 38, enter 36, enter 60, 30, oh, after that 36, no, after that is 68, right? 68, enter, and then 56, enter, 54, enter, and then 66, done. Now stats, 1 var test, list 1, not list 3. So let me just screenshot that there so that I can easily quote it. So my sum of x is 693. My sum of x squared is 41,725. The sample mean is 5775. Sample standard deviation is 12.44716. Oh, what is the variance? Do you know what is the variance? How to find the variance? You square that number. Okay, so I will get 12.44716. Let's get more decimal, 10 something. 105, and then square it. 154.93182. 154.93982. Is it right? 93182. Okay, I used this earlier so that I don't need to go back and forth the calculator. Now let's see step part B, test at 3% significance level, that if the overall mean of Secchi measurements is less than 65 inches. So step 1, let me use blue. I usually use blue for my solution. Step 1, the claim. The overall mean of Secchi's measurement is less than 65 inches. Now, because of space, if you think you won't have enough space, break it into 2 parts. Let me say the following. Make it into 2 columns. That way you have more space. Okay, step 2, hypothesis. Mu is less than 65. That's mu is greater or equals to 65. Now the claim is here, and therefore that's a left tail. Step 3, test statistic. We'll use t-test because we don't have the standard deviation. Okay, and that is 57.75 minus 65 over 12.44716 over square root of 12. As I remember, there are 12 data, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now then go back to my calculator, go to stats, t-test. The mu naught is 65. X bar is 57.5. Sample standard deviation, let me make it 12.71, 12.44716. Sample size 12, and then we will do left tail, calculate. Let me borrow the space a little bit. So this is negative 2.01771. The p-value. So p-value is TCDF negative E99, negative 2.01771, and degree of freedom is 11. Right, degree of freedom is 11. And the p-value is 0.03434. Oh, just a slightly greater than 3%, huh? Okay. So then my step 5, informal conclusion. Fail to reject null hypothesis. And step 6, conclusion. At alpha equals to 0.03, there is insufficient evidence to support the claim that the overall mean of Secchi measurements is less than 65 inches. Extra credit, critical value, 3% on the left tail, and that's T critical. It's inverse T, 0.03 degree of freedom, 11. Negative 2.09614. Negative 2.09614. Okay, now that's our step, our page 2. Oh, I have more space down there. I didn't realize that. Number 4. Suppose a researcher believes that college faculty vote at a higher rate than college students. Let's see. Yeah, that's the only question for this page 3. She collects data from 200 college faculty. So sample size is 200. Oh, that's for the college faculty. And college students, 200 also. You know what? Let me move this to the right. And then the number of faculty voted in the election is 167. The number of students voted in the election is 138. The alpha is 5%. Is there enough evidence to support the researcher's claim? What is the researcher's claim? The claim is college faculty vote at a higher rate than college students. Step 2, hypothesis. So alternate hypothesis P1 is greater than P2. That's what the claim says, right? But I modified that so that I have constant on one side. Notice that our claim is in the alternate hypothesis, and that's a right tail. Now let's use calculator to get those informations that we need. Those are what is P1 hat, what is P2 hat, what is P bar, and therefore Q bar. P1 hat 167 over 200. I don't think I need calculator for that. That's 0.835. P2 hat 138 over 200. That's 0.69. So P bar is 167 plus 138 over 200 plus 200. That will be 200, 305. Huh? Okay, let me use my calculator. So stats 2 proportion C test. X1 167 and 1 is 200. X2 is 138 and 2 is 200. And we are doing right tail test. Calculate. Let me use my screenshot. Put it somewhere here. Sorry. Yeah, to help me copy that down, right? So that will be 0.7625, and therefore this is 1 minus P hat, that's 0.2375. So then test statistic. C equals to P1 hat minus P2 hat minus P1, P2 from the null hypothesis over square root of 0.7625 times 0.2375 over 200. Actually, exactly the same thing here because the sample size happens to be the same. Let me move this down here. So this is equal to, the C score is 3.40735. So the P value, C score, right tail, P value is normal CDF 3.40735 to infinity 0.99. I mean E9901. That will be 0.000328. What is the alpha again? 5%. Okay, I don't need this anymore. So the purpose I use calculator actually just to get my step 3 and step 4. So step 5, informal conclusion. Reject null hypothesis. And then step 6, conclusion. At alpha 0.05, there is sufficient evidence to support the claim that college faculty votes at a rate higher than college students. Yes. Okay, extra credit, critical value. It's a right tail, and I think alpha is 5%. So critical value is inverse norm. Area to the left is 0.9501. That's 1.644 something. 64485. Let me see. Yeah, 64485. That's for page 3 of this test. Let's go on. Number 5. It was hypothesized that the elder brother E of twin pairs was slightly taller than the younger one. The answer will be no. When you want to talk about slightly taller, you cannot do it this way. When we say slightly taller, the thing is like when we still need to come up with a sample where the elder brother is significantly taller instead of just simply slightly taller. Like slightly taller when it comes to hypothesis test is something we cannot really prove. Well, it's not proving that we cannot support by the data, because our data will need to come up with significantly taller to come up to that conclusion. So the word slightly taller, the word slightly is actually hard to argue. Okay, it's kind of hard to argue. Well, anyway, let's see. Find the difference in the last row above. Let me just go ahead using calculator, okay? Where I will punch in all the numbers. Let me see. Only list 1 occupied. So stats clear list 1. Okay, now then I will enter input the data from list 1. So the first number is the elder, 72, 67, 64, 71, 66, 68, 72, 65. And the second row, 71, 70, 65, 69, 70, 66, 71, 63. L3, go to heading L1 minus L2. Then they will occupy that for us. But we can actually compute that quite easy here anyway. Right? Yeah, we can easily put that in. Now, the reason I use calculator is actually to do one variable stats for list 3, not list 1. Oops, for list 3. So you see the sum, oh, the x bar is 0. Okay, so the sum of d is 0 and the sum of d squared is 40. Oh, okay. And then find the mean and standard deviation. Make sure you show work and proper notation. Okay, then d bar equals to the sum of d over 8. That's 0. Okay, standard I'm sorry, sample variance of the differences will be 8 times 40 minus the sum of d squared over 8 times 7. Is right? Okay, that's basically 40 over 7. That's 5.714285. So standard deviation will be the square root of that number. That's 2.39046. Wow, is it? Let me make sure I don't punch anything wrong. So -2, -3, -1, -5. Oh yeah, the sum of the data is 0. Okay. Now then, part D, alpha is 0.05. Test the claim that the elder brother of twin pairs tends to be taller than the younger brother. So hypothesis, the mu of the elder brother tend to be taller than the younger brother. But that means the mu of the difference is greater than 0. It's a match pair, right? Mu of the difference is at most 0. This is the claim. That's a right tail. Step 3. Test statistic. Statistic T equals to D bar 0 minus 0 over sample standard deviation 2.39046 over square root of 8. I guarantee this is 0. Okay, now then, how about the p-value? The test statistic is exactly 0. Okay, so the area to the right must be 50%. So that's TCDF 0 E99 7, but guaranteed at 0. You know what? Let's check stats, test statistic, T test, input data, the stats there. Mu naught is 0. The X bar is also 0. Sample standard deviation is 2.390446. And we want greater than 0, so that one is correct. Calculate. See? Yeah, because T score, C score equals to 0. It's right in the middle of that curve. Okay? Yeah, it's right in the middle of that curve. So the P value will be 50%. Okay? Not 0, not 0. It's 50%. Now then, informal conclusion. Fail to reject null hypothesis. And step 6 conclusion. At alpha equals to 0.05, there is insufficient evidence to support the claim that the elder brother of twin pairs tends to be taller than the younger brother. Tend to be taller than the younger brother. Okay, 4B for extra credit, critical value. That's a right tail. Alpha is 5%. So T critical is equals to inverse T area to the left, 0.95, degree of freedom, I believe that's 7. So inverse T area to the left is 0.95, degree of freedom 7. 1.89458. 1.89458. Now that's for page 4. I have only approximately 10 minutes left. And we need to do this number 6. To compare customer satisfaction level of two competing cable TV companies, customers of company A and company B were randomly selected and were asked to rate their cable companies on a 5-point scale, with 1 being least satisfied and 5 most satisfied. The survey results are summarized in the following. And the question is company A better than company B? Let's call that our claim. So this is actually comparison of two means, right? Okay, and that's not match pair. This is independent case. So company A is better than company B. Step 2, hypothesis. Null hypothesis, alternate hypothesis. This is mu A is greater than mu B. Because it is independent case, then mu A minus mu B greater than 0. We don't make it into mu difference, no. Okay, mu A less than equals to mu B. So the alternate, the null hypothesis, mu A minus mu B less than equals to, this is the claim, and that's a right tail. Step 3, test statistic. T equals to XA bar 3.51 minus XB bar, that's 3.24 minus mu1 minus mu A minus mu B over square root of variance of the first group squared over 174 plus variance of the second group squared over 355. Let me use calculator. Test, that's 2 sample t-tests, right? Okay, and then I will insert the informations. X1 bar is 3.51. Sample standard deviation 0.51. Sample size 174. X bar 2, 3.24. Sample standard deviation for the second group 0.52 and sample size 355. We will do a right tail test. It's not pulled. That's the number. Now, unfortunately, they use different degree of freedom than ours. Okay, they use different degree of freedom than ours. So let me check that using calculator later on. Okay, but let me put it here for now. You can put it here. Now I will use calculator to actually compute that. So parentheses 3.51 minus, because they use different degree of freedom. Okay, now our t-score test statistic should be the same though. The square root of 0.51 squared over 174 plus 0.52 squared over 355. Do I make a mistake? The number's supposed to be, oh, you know, it's actually right, 5.68387. 68387. So you see that we get the same result with this, right? Okay, now our p-value, however, may be different. Okay, our p-value may be different. The thing is, like, if we round to 5 decimal places, it should be 0. Okay, and this is a right tail. So the p-value is TCDF 5.68387 to E99, degree of freedom 173, the smaller number. Notice that they use different degree of freedom. Okay, but I believe the result will still be 0. Okay, so TCDF lower bound 5.68387, upper bound very big number E99. Degree freedom, I use a smaller one because I try to be more conservative. So I get 2.745 e to the negative 8. That's approximately 0. 2.745 times 10 to the negative 8. Maybe I write it that way. That's 2.745 times 10 to the negative 8, which if we round to 5 decimal places, it will be 0 anyway. Okay, now then I'm done with this guy here. Let me just erase that. Then go on with step 5, informal conclusion. Reject null hypothesis. And conclusion. What is the alpha? 5%. At alpha equals to 0.05, there is sufficient evidence to support the claim that company A is better than company B. I love that short claim. Okay, for extra credit, about critical value. We want 5%, right? Right tail. T critical is inverse T, area to the left, 0.95, degree of freedom, 173. One 1.65371. 1.65371. Okay, instead of only having 4 questions answered, I answered 4 pages answered. I answered 5. The time I have left is only 3 minutes. But let me go over this number 7, the most common mistake, the most common mistake. What happened here is we will compare two proportions. Okay, a local school board member randomly sampled private and public high school teachers in his district to compare the proportion of national board certified teachers in the faculty. Now the result were in the private school of 80 teachers, 17.5% are certified. Now, can you find out what is the X? Now, we know that the formula is P hat equals to X over N, right? So the X will be N times P hat. Okay, in this case, that will be 18 times 0.175. You see what I mean? This question is not from me though. So it's not that I try to give you a curveball. No, no, no. I just copy paste one of the question from a university. So if they ask it there, then you're supposed to know. So this is 14. Now x2 will be 520 multiplied by 15%. That is 78. Okay, so that's what we have here. Actually, I happen to answer it here. Now find the proportion of NBC, National Board Certified Teachers in the faculty. So that will be P bar, if these samples are pooled, it will be 14 plus 78 over 80 plus 520. That's 92 over 600. That's 0.15333. Now then, question number part C, basically the hypothesis test. Okay, I will not do that in full, at least I state the claim. The claim, the hypothesis that the proportion of National Board Certified Public School Teacher is less than the proportion of National Board Certified Private School Teachers. Okay, but pay attention. They use less than, but in the notation there, the public school is actually with the second group, not the first group. Okay, so be very careful when you plug in the second step, hypothesis. Okay, be careful when you do the hypothesis. So P2 is less than P1. Okay, you complete that yourself. And this is where I will stop. The time's up, right? Okay, extra credit from number 7. Oh, that's from number 7. So that's the last page. Can you construct 95% confidence interval for that? Can you do that? Thomas, you never teach that though. Oh, implicitly I did. So first one, what is the best point estimate? Best point estimate is P1 hat minus P2 hat. Critical value, that will be C score. 95% in the middle, right? Okay, so it will be inverse norm 0.97501. I believe the number is 1.95996. Margin of error will be 1.95996 times the square root of P bar Q bar over N, the total data, okay, and then 95% confidence interval for P1 minus P2 will be whatever you have there, P1 hat minus P2 hat minus margin of error less than P1 minus P2 less than the best point estimate. Let me just use this as the best point estimate here. Plus margin of error. So Thomas, what n do we use? You use the n, the sum of n1 plus n2. Okay, again, this is where I will stop. See you next week with your tests ready.